Welcome back to our Software Design and Development unit. In this lesson we will look at selection constructs and operators. We will find out how the computer makes decisions based on conditions that have to be met. We will also look at the sequence of instructions or the order in which instructions come, and we will investigate why it's important that those instructions come in a particular order when we're writing a program. As always, we have some learning intentions. Today our learning intentions are: we'll learn how decisions are made in a program through the use of conditional statements. We will learn how simple and complex conditional statements are created and the purpose of comparison and logical operators. Our success criteria is as follows. We'll be able to sequence commands correctly in order to solve a programming problem. We'll be able to describe the purpose of the 3 logical operators and identify when it's appropriate to use them. We'll be able to describe the purpose of the 6 comparison operators and identify when it's appropriate to use them. And we'll be able to implement if else, if statements using simple and complex conditions. As always, our success criteria should be used as a tool throughout the lesson. You should refer to this frequently throughout the lesson and gauge how well your knowledge is improving. When creating a program or executing and running a program, the program will execute each instruction in a particular order. The basic definition of a program is a set of instructions that is executed in a sequence or order. That order will be from top to bottom or start to finish in this case. The example of the program we have here shows values being assigned to 2 variables, the width of a rectangle and the height of the rectangle. We are assigning these 2 values before we use the variables in a calculation. The result of that calculation is then stored in the variable area and displayed in the list box. In this case, the result and what will be displayed using the variable area will be 50. As mentioned earlier, when developing any program, it's vital that we place our instructions in the correct order. This will allow the program to work correctly. If we have the correct instructions in the incorrect sequence, then this will cause a problem. Again, our program will be executed from top to bottom or start to finish. And in this example, we are now trying to calculate the area before we actually take in the values of the width of the rectangle and the height of the rectangle. This will result in our list box displaying the value of area. In this case, the value of area will be 0. Sometimes we don't want all of our instructions to be executed at once. There are times when we only want instructions to be executed when certain conditions are met. The developer will make use of selection constructs to do this. This allows the program to make decisions based upon whether input from the user meets a condition. An example of this is an if statement. We can see an if statement in the example code we have here. In our example, the user is asked how many bits are in a byte. Their response is assigned to the variable answer. We then enter the selection statement or the if statement. We check to see if the value in answer is equal to 8. In this case, the piece of code answer equals 8 is referred to as the condition. If this condition is met and true, the instruction will be executed and correct is displayed in the list box. If not, then the instruction is not executed and the program ends. If statements are really effective in allowing the computer to make decisions. They also allow us to improve the efficiency of our code by only executing instructions we want executed at certain times. As mentioned earlier, if statements allow your program to choose and execute one instruction or a set of instructions over another. This will be based on the contents or the values of specific variables within the code. These variables are normally contained within our condition. Again, in our example, answer equals 8 is our condition. If statements make decisions based on conditions. Conditions are made up of the value of a certain variable being compared to the value contained within another variable or an item of data. If the condition is met, it's regarded as true. If it is not met, it is regarded as false. If the condition is true and is being met, then our instruction or set of instructions will be executed. The structure of our if statement is as follows. We have our key instructions if, then, and end if. Our statement always opens with if and ends with end if. In between the if and then we have our condition, and then we have our value if true, and that is normally our instruction. Our if statements can also contain else statements, and these operate in the exact same way as a normal if statement, only we have another instruction that can be executed if our condition is not met or not true. In our example here, we have our if statement being opened, our condition, which is answer equals 8, and if that condition is met or true, then the first instruction will be executed and correct will be displayed in the list box. If that condition is not met or false, then the second instruction will be executed and incorrect will be displayed in our list box. We are now making the decision whether to execute the first instruction or the second instruction, depending on the result of that condition. If-else if statements allow us to evaluate and use additional conditions that will allow alternative instructions to be executed. In our previous example, we had the option of 2 instructions that could be executed. One if our condition was met and one if our condition was not met. In our example here, we have 2 conditions now. If age is less than 13, then if that condition is met or true, then child will be executed and displayed in our list box. Else if, which allows us to evaluate our second condition, which is age is greater than 19, and if that condition is met and true, then adult will be displayed within our list box. Our second condition will be executed. And finally, if neither of the 2 conditions are met and both are false, then the third instruction will be executed and teen will be displayed in our list box. This allows the computer more options when it comes to executing instructions. While we have been looking at if statements, one of the key areas we've highlighted is our condition. Within our condition, we are always making a comparison. Sometimes that is one variable against another variable, or a variable against a piece of data. To do this, we compare values. In order to compare those values, we need at least one comparison operator. These comparison operators are used for evaluating conditions in our if statement. In our example here, we have a less than comparison operator in our first condition and a greater than comparison operator in our second condition. Some other comparison operators are displayed within the table in our slide. All of these comparison operators can be used within our conditions in our selection statements. Logical operators are sometimes used within our selection statements. There are occasions where we want to make decisions based upon two or more conditions being met. This is sometimes referred to as a complex condition. In our example, the AND logical operator is being used. This means that both conditions, name equal Lisa and password equals Sue, must be met and regarded as true for our first instruction to be executed. In our example, if name equals Lisa and password equals Sue, then our first instruction will be executed and entry gained will be displayed within our list box. If either of the two conditions are not met or regarded as false, then our second instruction will be executed. Entry denied will be displayed within our list box. We can see other logical operators within the table. OR means that one or the other condition must be met in order for our first instruction to be executed. We can use the NOT logical operator when we want our condition to be false. That brings us to the end of today's lesson. We hope you enjoyed it and learned something new. There are plenty more lessons in software design and development here on our channel. Don't forget to tell your friends to visit Gri-Fi Business and Computing Science on YouTube, and please don't forget to subscribe.